Okay, so let's take a look at some more questions. So the first one here, we have for a transformer with a 1000 turn primary coil, what potential difference is available in the 200 turn secondary coil when the primary voltage is 230 volts AC? Okay, so we're going to draw a picture of our transformer. So for this first one, transformer pretty much looks like this. It has some coil coming in, wraps around some number of times, some coil going out, wraps around some number of times. We are told the voltage, the primary voltage here is 230 volts AC. We're told the number of turns on the primary side is 1000. We're also told the number of turns on the secondary side is 200, but we're not given the voltage secondary. Right, so Vs is our only unknown in this question. Well, we know, using one of our ideal transformer rules, that voltage primary over voltage secondary is equal to number of turns primary over number of turns secondary. We need to rearrange this for Vs because that's the only thing we don't know. So multiply both sides by Vs, divide both sides by Np, multiply both sides by Ns. This gives us Vs is Vp times Ns on Np. Vp is 230, Ns is 200, Np is 1000. So we've got 230 times 200 over 1000. You put this into the calculator and you will find that voltage secondary is exactly 46 volts. So we're able to calculate this using our ideal transformer rule, the Vp on Vs is Np on Ns rule, and this came out to be an exact number. Now we have a second question here. The question just below it reads that an AC transformer is connected, a transformer is connected to an AC source that delivers 30 amps. The secondary coil delivers 10 amps. We are asked what type of transformer is this, and to calculate the ratio of the number of turns. So let's draw a picture of this transformer. It usually helps to draw a diagram. Almost all the time in physics, if you are not drawing a diagram, you're doing something wrong. So we have an input coil like so. We have an output coil over here like so. We have been told that the current primary is 30 amps, and we have been told that the current secondary is 10 amps. We have not been told either of the voltages, so there is a voltage primary here and a voltage secondary here. We don't know what they are. And we have not been told either of the number of turns. So number of turns primary, number of turns secondary, we don't know any of this. Now we have two ideal transformer laws. One of our ideal transformer laws links voltages and currents. So we know, this is the power in equals power out rule, that Vp Ip is equal to Vs Is. Now if we plug in Ip and Is, this tells us that voltage primary times 30 is equal to voltage secondary times 10. If we rearrange this, this tells us voltage primary is 1/3 times voltage secondary. And this means that voltage primary must be smaller than voltage secondary. So this implies that voltage primary is less than voltage secondary, and this tells us that this is in fact a step-up transformer. Right? So the secondary voltage is greater than the primary voltage. This implies that this is a step-up transformer. So this is the first part of this question. This is the answer to part A. Now for part B, we're told to calculate the ratio of the number of turns. Well, now we need to use both of our transformer rules. So we know that Vp Ip is equal to Vs Is. We also know that Vp on Vs is equal to Np on Ns. So we're going to rearrange this first one, divide both sides by Vs, divide both sides by Vs, divide both sides by Ip. This cancels these Vs's, cancels these Ips. It gives us Vp on Vs is equal to Is on Ip. Now, Vp on Vs equals Is on Ip, Vp on Vs equals Np on Ns. This implies that Is on Ip is in fact equal to Np on Ns. Np on Ns is the ratio of turns, right? Ratio of primary to secondary turns. Depending on how you rearrange this, you could have it secondary to primary, but this is the primary to secondary ratio. We know Is, we know Ip. Is is 10, Ip is 30. This means that 1 on 3 is equal to Np on Ns. And this tells us that the ratio of the number of turns on the primary coil to the number of turns on the secondary coil is equal to 1 to 3. Right, for every 1 on the primary coil, there will be 3 on the secondary coil.